And thank you. This is the second session. We have the four speakers, including me, and the fourth speaker will deliver his talk, Dr. Banerjee, through VC. First, because we have given the time 90 minutes, each speaker will tell 20 minutes. 10 minutes will keep for the question and answers. First, I am requesting Mr. R.R. Satpathy. He is the ED of Exploration and Beneficiation, Lawyers Metal and Energy Limited. He was earlier in Tata Steel in different positions in India and abroad. Now he is working in the Lawyers as ED, Executive Directors of Iron Ore Beneficiation and Exploration. Now I request to Mr. Satpathy to deliver the talk and please keep the timing within the 20 minutes. Thank you.
Hello. Thanks, sir. So, good afternoon. Very good afternoon to everyone on the dais. Very eminent mineral processing scientist, Dr. Biswal. All my eminent speakers on the dais. Of the dais, all the seniors and legend of the minerals and mining sectors. All my young colleagues, respected ladies. Once again, thank you. Thank you, SGAT, to give this opportunity to Lloyds. Lloyds is Maharashtra-based industry. We are having our iron ore business, both mine to mill at Maharashtra in two districts. One is Gadchiroli district and another is Chandrapur district. So, first of all, the topic is dynamic of mineral sector in VIKSIT Bharat. So, my next slide is uh, if you talk about the VIKSIT Bharat, so one of the major KPI is this. This is the major KPI, one of the major KPI, 10 trillion economy by 2047. So this mineral sector's goal is also towards that. And if you see that in the bottom, the power, steel and mine sector contributes one of the major role in that 10 trillion ton economy. My point of saying is, whatever we have discussed in the first session, even though in the inaugural session, first session, and whatever we are going to declare in the subsequent sessions, all should be towards this. Everybody is speaking towards this, or I will also speak towards this, but my mostly thing is low grade BHQ, BHJ, or in very nutshell, it is how to create wealth from the West. West, I am saying, West is BHQ and BHJ. आज का दिन में फेंका हुआ है, आइदर माइंस में हम लोग ओवरऑल डंपर में उसको फेंक दिए हैं या फिर हम लोग माइन नहीं किए हैं. माइन करना दूर का बात, एक्सप्लोर ही नहीं किए हैं. हमारे जीएसआई के सीनियर कॉलीग इज हियर, सो that's why I am telling you everything towards waste to wealth in this particular. We have to understand three things. Why? If you understand this why, then how will be easy. Otherwise, there will be lot of question in how. Is it economic viable? Whether I will be get region from the premium regime or this auction regime, why I will do this mining when I am taking in such a high premium in auction. Lot of why will come when we will go to how. So it's better to clear the why first. If you see in this entire audience, If you see, there are more than 50 ages, there are more than 60, more than 50, and there are less than 45. Young mass is there. So what will happen? A lot of exploration data has been told or has been explained by our GSI friends, and maybe we all are thinking iron ore deposit which is suitable for making the steel is plenty in this earth, and we all are taking Odisha is major in that. First, park that mindset. Park that mindset. It is not like this. In the substance, it is not like this. Then I will go, how is nothing? It is a mix of technology and some policy things, which will make us to happen that BHQ or waste to wealth in iron ore. And I will touch upon what Lloyds is doing there. We are establishing a BHQ beneficiation plant, which will going to be start. We are almost like Pranigari sir was told in the first session. We are waiting for the EC. We got the tour. Public hearing date has been announced. So we'll go for a EC, and our entire engineering and design has been completed. Total project cost is around 5,500. Out of that, 1,000 order already has been, we have already given the technological order, those who are high lead. So we are in an advanced stage. We'll speak about that. I've already talked about that. Let's see what is the steel scenario of India. China is best. China is highest. Okay. We all are saying India is second highest. But here सबसे ज्यादा चीज जो गौर करने वाले see the gap. One is 1,000, one is just touching 200. We are second. That's why what is our national steel policy in 2017 has been this the direction of the nation. Whatever we are telling, whether it is a rare mineral, iron ore, manganese, we have talked about, coal, we have talked about, every mining must have a national interest. Then it is the interest of the owner or interest of the miner. The national interest by FY 30 will do 300 million ton of crude steel, and by 2047, when we are going to complete 100 years of our independence, there it will be 500. Just remember these two figures. This is the national interest. This is all about what we are doing. I don't know, resources India. Our GSI senior colleagues are here. Very right hand side top, we are showing there are total, if you see, around 34 billion ton of resource. It is both hematite and magnetite both. But mostly if you come to the hematite, it is 24. And how it has distributed. In the Indian map, H stand for hematite and M stand for magnetite. How it was distributed in entire country. And again, if you see, when you are second in the very left hand side, when we are second in the world for steel production, we are seventh as far as the iron ore resources in India. Come to sequentially the next slide. Production, we are fourth. Steel, we are second. Resource, we are seventh. Production, we are fourth. Just remember this sequence, how imbalancically our country is going. And captive, non-captive, okay, I'm not going to that here. Then you come, this is in FY24 how the production is in the India. We are growing in a very very rapid rate, almost close to 10% that iron ore production is going. But I'll take you to this slide. As this slide is little hazy, yeah, it is also hazy to my screen. Yeah, thanks. Thank you very much. So, if you just see this slide, FY 30 will reach 300. So, we will require around 0.5 million ton of iron ore. In FY that 2047, 500, that was very close to 1 billion ton iron ore we required. Okay, scrap will come, it will replace. The way our country is going for the scrap route, it is already started. One plant by Tata Steel has placed in Ludhiana. It has, and some other steel makers are doing, but it is in a very slow speed. So at least next 100 years or 150 years will depend upon iron ore. Slowly, maybe some of the portion of the iron ore will buy scrap. That will also happens. But our dependency. So 1 billion ton iron ore is required, whereas 33, 34 is the resource. Out of that resource, if let's assume a very theoretical things, all this resource is converted to a reserve. Let's assume theoretically. There will be definitely maximum 60 or 70% will come economic viability. Then it will be coming to 24, 25. 1 billion ton required. That means why I have told age group. The people, those who are sitting below 45 years, and by the time 247 will achieve 500, finish, I don't know. So what these people will expect from us? What current practice should be? Everybody will talking about the economic viability, economic viability. Economic viability, today cut-off is very good. There are few, those who have started coming down to 50 cut-off, where threshold is 45, but mostly it is 55. And those who are not having beneficiation, directly 62, because steel is required, anything 62 plus. So if we will cut the only in 62 plus, that is only 6.7 billion ton. This is just, I have, this is not an exact representation, but I have tried to picturize it to make all of you a very simplified way of understanding this. 6.2 currently we are enjoying. Mining, the blue person giving all 62 plus, because I have taken a mines with 121 premium. So I'll try to maximize my profit, and in the same time steel plant also has to be run. So we are enjoying that. But yes, JSI has shown very extensively, exploration is on by GSI, by MECL, by a lot of private parties also. Maximum possibilities, this will go up to 24.06. Economic viability, 55 cut off, 45 to 55 in the mines as a subgrade, less than 45 untouched. Okay, so what will happen? How, see the China model. I'll just spend 1 minute. China is, what is the model of China? I've spent sufficient time in China. That model is two things. One, their R&D, technological development, is very high quality. They have very excellent R&D center. They spend good amount of money in R&D before the project. Now in India, what is happening? Hundreds of papers are there by the scientists sitting here in R&D center about this BHQ, BHJ, or we are talking about low grade manganese, or we are called low grade chromite. Hundreds of papers are there. 4 to 5% are commercialized. In China 33-35% is commercialized. Their R&D center से जाके commercialize होता है. That means our R&D is inadequate. It is not because of we don't have the scientist. Our scientist, even though it is China, I have seen our scientist. Even though it's South Africa, Mintech, it is our scientist, Indian scientist. If it is Australia, it will go to Hatch, Indian scientists are there. It is not that we don't have scarcity of scientists. It is only we don't have R&D center which will updated every year. It is just like a software. Next year, next software will come to the market. R&D also like this. And second is miners or the businessman is just, we are must believe in copy and paste rather than discovering something or inventing something or trying to touch the world in a different way. We are better copy. ऑस्ट्रेलिया में हो गया है, चले इंडिया में ले आते हैं. What again? China is doing very silently. वो बाहर नहीं बताता है. Google Baba is not allowed there. They make it very silently. I have spent almost 3 months continuously just for this purpose. I've gone to their major R&D center, gone to BHQ, BHJ. They are doing from 2009. Less than 45. When I have told ki our ore is like this, our BHQ is 34 cut up. Oh, it is a high grade. Because we have maximum 41, 42%. Then what is China model? They have the reserve of 40% of this kind of material, both hematite and magnetite, BHQ and BMQ, BHJ. And from there, they invest, they do the state of art process. Yield will, you have to sacrifice on yield. Waste जब कर रहे हैं तो आपको sacrifice करना पड़ेगा yield को. And it is, and you see that very good. In the morning also I was listening recirculation mining. और आई एम टॉकिंग वेरी गो टू वेरी एंशिएंट डेज. आप लोग सब, हम लोग गांव में रहते हैं. जब हम लोग गांव में थे, जब साड़ी पुराना हो जाता था, मेरा नानी माँ उसमें, हम लोग उड़िया में कंथा बोलते हैं, उसको सिलाई करता था. जब कंथा पुराना हो जाता था, उसको लेके पोछाई करते थे घर का. जब वो पुराना होता था, उसमें जाके चूल्ही की पोछाई करते थे. देन डिस्कार्ड का लेवल में आता था. दिस इज दैट टाइम, फ्रॉम दैट टाइम इट वाज देयर. We are not talking anything new here. We have to have new approach to that. China 25 से 30% yield में अपना iron ore कर रहा है. From India he is getting very good, less than 58. There, if you go to their business deal, मेरा alumina and silica इतना होना चाहिए, phos इतना होना चाहिए. Fe less than 58, okay. We also have some legislative policy, we cannot do that. And from Australia, Brazil and Kumba, South Africa, Kumba, Anglo, they got the super grade plus 65, super less than 1 alumina, and phos 0.001, and silica is also less than 1, less than 2. They mix it, everything in China. They make the steel, they are highest producer of steel, and their cost of steel is very much under control. But here we are thinking, because of now we are using this top band, or in future we are thinking we are having plenty of that blue band. So we are thinking, we are also maintaining cost in steel, but because of this blue, not because of this gray. And 2047, the blue is finished, maybe. Some of the blue will add, always GSI is doing a lot of things. Somewhere something will add, OMC is getting something. So definitely something will add, but that will be 5 to 10% range or 20% range, sir, in that blue band. But that 45 to 55 will remain in the mines. Less than 45 will be untouched. All these are gray. Then in after 2047, we will achieve 500. After that, what? विकसित भारत खत्म तो नहीं हो जाएगा सर. Next aspiration is to touch the China. The gap is 500 and 1000. Another 500 is there. This, all these young guys sitting here, that is the aspiration for them. Then we'll say that we want to be number 1 in world. Definitely the aspiration बढ़ेगा country का. From where? Then we'll say we are having a lot of gray iron ore. The yield is 25 to 30% or maximum 35%. How where the cost will go that time? What will be the input cost of iron ore that time to the steel? And that time already decarbonization kind of a things will come. You just couple of days back, Minister of Steel circular has come about the green steel. 5-star green steel, 4-star green steel, 3-star green steel, and they have given only one measurement, that is CO2 emission per ton of crude steel. If you are 1 to 1.6, you are in 5-star band. 1.6 to 2, you are in 4-star band. 2 to 2.2, something like you are in 3-star band. There is no star below that. So that thing will also come to iron ore. So that pressure is there. Input cost is there. So our steel will be much, much costlier than the China and Japanese steel. Then as an Indian, if I'll go to purchase some steel item, whether it is my house or it is my household or construction, or I will say the China steel, yes, it is available is 3,000 ton, and Indian steel is available 9,000 ton. As an Indian, what we will choose? We'll choose 3,000. We cannot say, oh, I am Indian, I'll ready to pay 9,000. I am a great Indian. No. So why, understanding why is very important. This why is, and those who are, I am already approaching 60. So what we'll see? 2047 बहुत दूर है, मेरा पीरियड तो पार हो जाएगा. देखेंगे वो लोग, बच्चा लोग क्या कुछ तो कुछ करेंगे. So that is how the imbalance is happening. There is nothing bad to talk about that, and it is happening in our country. And our country construction infrastructure sector is in boom. It is doing one of the best in the world. Our demand, if you see one of the slide, our steel per capita has been gone to 80 kg per capita, which will expected to touch 150 in coming. That's why this target 300 and 500 has been taken. If I don't understand. So I will just, so how? Why? I think by that time everybody must only, yes, this has to be done. How? There are two things on the how. The benefit of this, first I will say, the benefit of BHQ, BHJ or BMQ, both are in the, is that very low alumina and very low phos, very low alumina. Na hai ya nahi alumina usme. Phos is very less, 0.001. Alumina is maximum, जो हम लोग कर रहे हैं अपना माइंस में, जिसको BHQ प्रोसेसिंग कर रहे हैं, 0.3. Can you imagine the what if this Fe, which is to be upgraded, and only impurities is silica, which is in the quartzite form, jasper form, and they are also in BMQ also quartzite, which is only silica has to be reduced. Fe has to be. अगर ये चीज हो जाता है, if this can be done with some process, then with this less alumina and less phos, what kind of a magic in productivity and in environment this ore will do in the blast furnace? Less alumina, less phos, fuel consumption will reduced by 30 to 40%. That much of coke will reduce, that much of coal will reduce, and that much of slag will reduce. Slag, which is producing now 240 to 60 kg with a good, today whatever the 63 Fe and alumina plus silica 6% we are using in the blast furnace, or 4%, it is producing 242 to 60 kg of slag, which will reduce to 110, 120 kg because of alumina to hai nahi. And because of the low phos, the high-end steel, we are talking about the high-end steel, gas pipeline, defense product, or high-end cars that require low phos. So benefits are there, and there are issues also, how to improve Fe and how to take care of this. This is the process. And one of our R&D partners is also sitting here, Dr. Biswal. We have also did this R&D, and this particular project will cost us 5,000 crores, and till now we have spent in R&D 310 crores. Lloyds has already spent in R&D, starting from exploration. This R&D should start from exploration, not that कि hematite drill कर रहे हैं, the moment BHQ और BHJ आ गया 5 मीटर करके क्लोज कर देते हैं. ऐसा नहीं किया हम लोग. हमने पूरा अपना 348 हेक्टर में 710 wire, we have purchased 7 high pressure drill machine from Australia and from US technology, which can go up to the 1000 meter, and till that 600 meter depth तक हमने इसको किया है. and 10 जगह BHQ को पंक्चर करके हमने मदर अर्थ को टच किया, दैट मीन नॉन मेटलाइज टच किया, लाइट को टच किया. 10 जगह अभी भी चल रहा है. First phase is over, and IBM mining plan is approved already, and that is one of the first mining plan जो कि BHQ as a resource approved हुआ है. Thanks to IBM, thanks to GSI, it has totally gone by both the agency have gone through that, because first time in the country we are going for this kind of telling BHQ as a resource. Yes, it has happened. And now after exploration, when we are doing the exploration, that time it is all depend how much risk ability appetite we are having, because when we are doing that in 1960 also that mines was explored. That time it was gone up to 70 meter. After that only 5 meter in BHQ they have stopped it. and we have gone up to 600 meter. अभी एक होल 600 क्रॉस करने जा रहा है. And we have seen two things. Inside BHQ also hematite is there, good ore is there, powdery ore. It is in the powdery form, but 66, 67. So technology is good. This technology, if you see this slide, except flotation, everything was there in 1980 and 19 Kudremukh. All this technology was there. In our study time from Kharagpur, we are going to see this Kudremukh mines, those who are having all this. But what is the wow factor? What is the wow factor here? Wow factor here, when you do the R&D and different lab scale, size reduction, this type of ore will start liberation in the finer size, 3 mm, 1 mm, 150 micron, 100 micron, 70 micron, then 45 micron. By that time it will liberate fully, it will fold. You have to be size it to such a fine size. So what kind of a sizing technology you use? If you go for conventional crushing, sag mill, ball mill, power consumption will be very high. Then you have to search for the good technology available in world. We have totally gone to Australia, Brazil, China. These three countries को तो हम लोग पूरा छान मारा है to choose the technology. There are technology. Got a HPGR as a technology, high pressure grinder, which is used in other minerals except iron ore. We have taken it for the iron ore and we are running it. 6 महीना से चल रहा है. Directly from 40 mm, it is taking it to 3 mm. 40% less energy compared to sag mill. So, okay. So, technology is not very important. Challenges. There are challenges, there are opportunity. We have talked about opportunity. अगर छोटा पार्टिकल करेंगे तो स्लरी पाइपलाइन, नो ट्रक इज रिक्वायर्ड, यू कैन नॉट ट्रांसपोर्ट, तो मजबूरन आपको स्लरी पाइपलाइन में ट्रांसपोर्ट करना पड़ेगा, व्हिच इज अ ग्रीन ये. सो नाउ पॉलिसी मेकर्स को क्या सोचना चाहिए और हम लोग को क्या सोचना चाहिए एज ए माइनर्स. एज ए माइनर हम लोग बोला कि एक्सप्लोरेशन हम लोग करना चाहिए, नॉट टू स्टॉप इट आज. ये एडवांस टेक्नोलॉजी का बारे में बात कर रहा था मैंने. एक्सटेंसिवली R&D करना चाहिए. We have to create an infrastructure, such kind of infrastructure to do this beneficiation. R&D का इन्वेस्टेशन करना, एडवांस टेक्नोलॉजी में जाना चाहिए. इन द सेम टाइम पॉलिसी मेकर को भी कुछ करना पड़ेगा. इफ यू वांट दैट कि इन इंडिया BHQ, BHG और लो ग्रेड क्या करना पड़ेगा. ओके, नाउ वी आर डूइंग अ गुड ऑक्शन, गेटिंग गुड मनी, 120, 140, we are not touching that. This is a revenue coming to the country and the states. But the moment mining will start in BHQ, because there is a waste, so you should not ask any royalty on that. You should not ask any premium on that, because when we have done that auction, that time it was all above 45. Based on that only auction has done. And me as a mine owner has gone for 121, somebody has gone for 141, somebody has got in 100 and plus. Good, very good. Everybody got the revenue. They have also calculated as per the, but when they, that will give the interest for that. Some other thing, I have talked about the reverse engineering and the royalty. I have talked about import duties. Most of the technology for use for this process is coming from China, Europe, USA. So import duties, now a lot of import duties are comment us to think about to make this BHQ, because yield is only 25 to 30%. Yield you cannot expect like 75, 80% like in hematite. It is that only. This is all Surjagarh iron mines already at this. We have done a R&D here, abroad, 5-6 lab in China. We have gone to country. We have totally discussed with all the greatest scientists of India. Visual Sub is there, IMT is there, IBM, Dr. Kanunga, everyone we have talked about. We have discussed with them. They have given a lot of suggestion. Then it was successful. First time when you have sent our drilled BHQ ore to Dr. Biswal lab, only one line has come. Yes, it is amicable and very good amicable for beneficiation. Then slowly हम लोग पैसा फिर R&D में लगाया. फिर we have running a pilot plant, 5 TPH pilot plant from May. From May continuously we are running a 5 TPH BHQ pilot plant. From 32 to 34 is feeding. we are getting 66 to 67. Now we are fine tuning to 68 Fe. The alumina in 67 will be alumina plus silica is around 2.6, 2.7. In 67.5 it is 2.1, 2.2, and the moment we are touching 68 Fe it is coming less than 2 alumina plus silica. Less than 2 alumina plus silica, 68 Fe. When you will make the pellet out of that, and this pellet will go to the blast furnace, that will be justify your green steel. You will have less fuel consumption, you will have less slag consumption, you will get a excellent steel which will be save you in the downstream. Almost we are on the track. First 2 into 15 45 mtpa we are establishing BSQ. 2 into 15 pa by 26 27 we are also coming with a steel plant. TOR has completed. We'll go for public hearing now. It is 4.5. We'll come with 7 in the first. It is 4.5. Then we'll go to another 3. So it will be around 7 million ton steel. Everything will be pipeline. Pipeline is completed, ready. In 3 months, 4 million ton pilot plant will start from March end or maximum by April. So this is how. And one more thing, I've just I'll complete it. Is that embarking green mining? We are going to declare it in our official website and officially for the country that maybe will be the first green mining in the India. We are planning it in the month of January. We are just waiting that we will get some prominent people around the world to make it happen. All our equipment in the mines is EV, electrical vehicle. Dumpers are electrical, 70-tonner dumpers. All the shovels are electrical. EX1200 Hitachi diesel we have converted in-house to electrical, and all are operating last 4 months successfully. All our drills are electrical. All our loading machines, loaders are electrical, and grader electrical is coming in a month of time. All our LMB used for our engineers for the shift managing, everything is electrical. We have tie up with Mahindra because lot of DGMS rules are applied there. So Mahindra has designed a rollover protection LMB electrical operator for us. 12 already we have purchased. So everything will be electrical, and we have already signed our energy 200 megawatt energy with Reliance Power and with Tata. They will give us the solar and wind energy plus. So our entire mines require 40 megawatt. Our pellet plant requires everything will be from the green power. So now last year it was 11.62 kg of CO2 per ton of ROM. This year we are operating 3.21 from 3.21 kg CO2 per ton, and when we'll complete this entire green, we'll come back to 2.7. Our plan is to reach 2, and our KPI in annual business, we are talking about only one KPI along with the product KPI for environment, that is CO2 emission. So thank you very much, and that's the time. Sorry sir, if I have taken 1 minute extra, I am very sorry for that. Thank you very much.
I was working as a scientist at Institute of Minerals Material Technology for 33 years. After my superannuation, then I joined as one private company, which is the first R&D private center International Prangraph Mintech Research Center at Bhubaneswar. My topic is the effect of iron ore characterization for its utilization and making value addition. Because mostly the people are basically the geology background. I am correlating how the characterization, mineralogy characterization is important. Any ore, not only iron ore, it affect for the development of processing and its value addition. The challenge faced by the steel industry in India, there are a number of challenges, but I will cover only raw material dependence on low and lean grade ores, which already Mr. Satpathy elaborated today, which is the BHQ, BHJ. Earlier it was thrown to the overburden. Today it is become the one of the best resource of iron ore. And apart from the raw material, the infrastructure and transport bottleneck morning already Mr. Ratha already elaborated about the logistics and regulatory hurdles. Last moment Mr. Satpathy told regarding the cost, that is the premium or royalty, it has to be, government has to be taken care so that the processing and value addition should be economical, viable. Recently, the government of India has put up the number of committees of the Ministry of Steel to make the new regulation so that the industry should not be suffer. And we have to do the global competition. Our major competition is the China, and technological lagging, demand in increase day by day. And we have also another part, you might have marked the skill manpower. Getting a skilled manpower is a shortage. And number of other problems ahead. Now I only cover of the raw material dependence. Now, as you, the geoscientist, as you know, the iron ore having the different types. Even same one of the same places you can get the percentage of magnetism maybe 1 to 2%, particularly Odisha ore, and mahamite, martite, and hematite. Because we are working now, not only India, in the internationally, we have seen the magamite, which is the gamma hematite, is also associated with iron ore, particularly in India, the Rairangpur samples, though it is called magnetite base, but when you do the FEO analysis, ferrous oxide is very less. But by beneficiation, by low intensity, you can get more. The reason is magamite is there, and if magamite is there, within the 2000 gauge you can able to attract. But if matrite is there, beta hematite, then you have to go to the medium intensity magnet separation to recover it. And alpha hematite is the normal hematite. Apart from that, our ore is mostly associated with goethite, either it in the vitreous or aqueous. Then the major impurities in our iron ore is the kaolite, which is, though we call the alumina silica, but mostly the alumina silica is contributed by three mineral phases. One is the kaolite, which is alumina around 39%, silica is around 45%, gibbsite and quartzite. Okay. Apart from that, we have the lean grade iron ore resources, which out of 35 billion tons, 11 billion tons is the banded magnetite quartzite. Earlier, Kudarmukh was operating by the based on the banded magnetite quartzite, but at present, because of Kudarmukh, due to environmental issue, it was closed down. But now, the based on the magnetite, one plant is running at present the Rajasthan by the Jindal Saw Limited, around 2 million ton capacity. And recently, one plant is coming up near to the Jhansi, that is the 3 million ton capacity based on the BMQ. Because BMQ deposition, it is not so easy to approach. That is the reason the beneficiation of BMQ is not coming very fast compared to the hematite. Then banded hematite quartzite, banded hematite jasper, and banded goethite quartzite. I think you might have heard the banded goethite quartzite, BGQ. It is available along with the BMQ in Rajasthan, which contain Fe content more than 45%. These are the ores, different composition, because you are, but if you see the processing as at present practice, what we are doing the mining, and first we are doing the screening, crossing and screening to generate the calibrated ore for the blast furnace or a DRI, and whatever the high grade fines you are generating, we are sending for sinter plant or pellet plant, and part of the which is the above 57% Fe, we are sending to the, for beneficiation plant to get the concentrate for pellet or pelletization. But most of the low grade ore having the below 55% at present we are not using. Either some people are blending with high grade and selling it. Otherwise it is lying on the mine sites. And BHQ, BHA only the first time they have started by the lawyers. The BHQ beneficiation they are planning. Otherwise it is lying on the mine site. If you together if you do it, BHQ, BHJ, BGQ and the low grade ores, if you are doing the 100 tons of the mining, almost 50 to 60 tons we are lying at the mine sites. These are the, we have distributed of the different ores starting from BMQ and high grade ores. Today, earlier high grade ore we are telling 64, 65. Today high grade ore is 62.5. Then medium grade ore, low grade ore we have divided based on the Fe value, and lean grade ore the BHQ, BHJ and BGQ along with the lot of slimes, because when you see the Tata Steel and Shell till today, they are doing the washing. They are not doing any beneficiation. They are removing the slimes. And the slimes and earlier tailings, which when it was the 50-80 the cutoff, a lot of slimes is lying in the Kirandul and Joda and Noamundi. And already Mr. Satpathy told that high demand, because we have proposed 300 million ton 2030, because of the corona, it has been revised to achieve 220 million ton in 2030. At present, we are producing almost 145 million ton of the steel. And it is required 350 to 370 million ton of high grade ore, either calibrated or sinter or pellet. For that, we have to do 800 to 850 million ton of the mining. And already 2047, we have targeted 500 million ton. We need the high grade ore around 800 million ton. That is the question. Either we will achieve or not. Regarding the decarbonization, we are at present 2.5 tons per ton of crude steel we are producing, and 2030 we are targeting 1.75 by adopting the new technology or new energy resources like the syngas or hydrogen, some other means. And we have proposed to make the net zero in 2070. That is the big challenges to us. And to replacement of fossil fuel by green energy like the conventional energy or use, and also hydrogen. And lot of availability of low and lean grade ore is there. Now we should be addressed to that. And the iron ore production last year, it was 2002 for around 270 million ton, and Odisha was 150 million ton was produced. So what is the actual challenge of Indian iron ore? This is the 30 to 70% of lean and low grade ore are generated in our mines. And it is associated with most of the clay minerals, and the goethite, which is associated with the hematite around 10 to 50%, and either in vitreous goethite or aqueous goethite. That is the reason our normal beneficiation, we call the conventional beneficiation, we cannot go, we don't get the better quality as well as also yield. And BHQ, BHJ, BGQ, all these things, it has to be beneficiated to utilize the demand. And economical and environmental sustainability of the process is the very, very essential today. Now the characterization, because before going to any ore, the characterization plays very vital role. Now the lot of advanced characterization facility like the XRD, MLA, microcity, TGDTA. Based on that, we should know the how it is associated, which minerals are associated in the ore. Based on that, we can plan the beneficiation process. Example, we are doing the microscopic model analysis, heating cycle or DT analysis based on chemical analysis. We do the quantitative analysis of the either how much hematite, goethite, kaolite, quartzite, all these things you can calculate. If you see the size analysis, you can see our ore, whatever clay minerals associated, all are in fine form, mostly below 45 micron. You can see below 25 micron only containing 34. If you can classify at 25 micron, which ore is 56, it may go to 61 by simple classification methods. Now the past we are doing the selective mining and we are doing only simple washing, and sintering process we are using the agglomerating the fines. Present washing is still continuing, those of the captive mines, and beneficiation, gravity and magnet separation has been built up around 150 million ton beneficiation plant in India. Sintering is continuing to utilize the fines, and pelletization started by the Kudaramukh, then it has expanded. Almost 140 million ton pelletization plant is there. According to the new policy of the steel, it is almost 300 million ton is targeted. Now the deep beneficiation which we have to do already, one of the example he has told Mr. Satpathy, graphite magnetic separation and flotation. And now those are not responding to the conventional beneficiation. IMT Bhubaneswar, we have worked last almost 20 years regarding the reduction roasting. That time it was not economical viable when the iron ore is available 1000 to 1500 rupees, because the reduction roasting process itself the process cost is around 2000 rupees. Okay. Today iron ore cost is more than 5000. Now today is economical viable. I showed the ArcelorMittal, the first they are planning to set up the reduction roasting process about the first trial for 3 million tons at Barbi. I will tell how the characterization effect to this when the plant was built up by the Isar Steel, the today's ArcelorMittal in Kirandul. That time they are throwing the fines which having the 63, 64, and we are beneficiating up to 67. That was the simple process flow sheet. We are doing it. Yeah. But now they have put up the plant in Odisha, the Damona plant, and because of the clay particles, the beginning you should remove the clay particles by the scrubbing technique. If it is the coarse particle, you can use the drum scrubber. If it is the fine particle, you can use the screw scrubber or screw classifier. One example you can see, this is the below 100 micron particles, around 25-26%. And if you remove by the screw scrubber, you can see this is the almost you are enriching to 62.81. That's why that is always a debate. So either whatever ore you do, beginning you do the disliming so that it will not affect the rheology of the process. And this is the another thing is because our ore is containing the goethite, our main problem is the how to control the grind. Normally, in other ores, other country, how to grind. That is the main headache. But our headache is how to control the grinding, because if the goethite is there, it become very, very ultra fine. It affect to the process, it affect to the dewatering, it affect to the filtration, it also affect to the pelletization. The all effect is there. That's why we are going, earlier we are classification either doing by the screen or by the hydrocyclone. But now you have to make the combine. Now the technology has developed the high frequency screen. By the cyclone and high frequency screen, you can control the particle size, because the pelletization plant one parameter they call the blend number. The blend number should be 2000, you can control. Earlier people were doing the blue dust blending with the other ores. When do the beneficiation, blue dust is going in the tailings. That's why blue dust is a high grade ore having the less alumina. You can make separate grinding and mixing at the filtration time, so that it will be the getting the better benefits. This is the one of the Kirandul plant, and on a Kirandul plant has been built up because it was 64 to we are getting 67. The simple process flow sheet was there. We are doing the spiral concentrator and manganese separation, achieving, because that time 58% was cut off, and we are telling containing 52%. But when the regulation has been changed, we have changed the process. You can see the additional red color. We have added the equipment to recover the more iron values to reduce the Fe content below 45%. And further value addition, we have put up the magnetic separation in the tailings so that iron recovery can be possible. And later on, we have also done a lot of optimization study, because earlier they are giving 63, 64. Now NMDC is giving 60 or 60 to 61. The mineralogy total has been changed. Based on the mineralogy study, we change the process flow sheet. This is the process flow sheet at present. We have modified to recover the more iron values with the 64, 65 grade based on the mineralogical studies. These are the weight bended magnetite quartzite. Sorry, bended magnetite quartzite. It is available at Rairangpur. When Tata has made the mining at the beginning, that time the overburden they thrown. The overburden contain 35 to 40% Fe having the magnetite. Okay. Now, because it has been lying for a long time, it is weathered. It has been magnetite converted to the maghamite. But maghamite can be possible to attract by the medium intensity and low intensity magnetic separator. We have done the process flow sheet around 35% yield with the 67% Fe. We have put up. Now they are putting the 10 million ton capacity plant to recover the iron values at a Rairangpur by amalgam stage. Already BHQ beneficiation, which I was supposed to tell, already he has explained. This is the Lloyd's flow sheet. And another issue is environmental issue. The earlier the tailing was allowed to putting the tailing pond. Now government has taken decision not to allow the tailings to tailing pond. You make a filtration. After filtration, you stockpile. The question is it filterable or not? That was the last 2 years debate was there. Now the pressure, earlier our pressure filter was 12 kg. Now 20 kg pressure is there. It can be filtered and you can stack it and you can make the artificial these things. And I am touching only reduction roasting process. It is the reduction roasting process. We are converting hematite and goethite to magnetite to facilitate easy to beneficiation. These are the different types of low grade ores. And once you do the along with the coal, because coal we are using in the rotary kiln. If you are the vertical kiln, you can use the syngas or any other gas, reductant gas, hydrogen, you can convert it to the magnetite. Okay. These are the color you can see. This is the low grade limonite ore. When you will convert it to reduction roasting, the color become blackish, and after beneficiation, we are getting the magnetite product. These are the chemical reaction takes place. I am not going details. These are the few examples I am giving. This is the 47% BHQ we have taken from the Karnataka. We can able to get 66% Fe with 72% recovery. These are the few examples I am giving. And Odisha ore, which having the 55% Fe, we could able to 80% yield with 65% Fe. Similarly, this is the another ore we are getting more or less same. And even those are ore of Rairangpur, because Rairangpur ore is siliceous ore. And it is responding to the reduction roasting very good, because the tailing containing 15% and concentrate getting 67%. These are the few examples I have giving. These are the process flow sheet. This is a simple process flow sheet, but only cost, because rotary kiln we are using, that was the additional cost is coming the process. That is the reason the process cost is more. But if you using it, we have calculated the economical viability. Within the 2 years, you will get back your money, like slurry pipeline. It has a lot of advantages, increasing 30 to 50% extra yield, increase the grade of the concentrate, and reduce the grinding energy, because you have heated, a lot of cracking happen. 30% energy you can reduce. Maximum the recovery process water, because it is easily filterable both tailing and concentrate. There is no clay effect here. Handling of the reject easy. It can be transported easily to the stacking. productivity of the process will be better because there is no clay effect, and you can easily transport. Your viscosity is less. Your power consumption for transporting through pipeline will be less, and easy to make pellet because you are again converting in the pellet magnetite to hematite. 20 to 30% energy you can save, improve the pellet quality, reduce the consumption of the ores. Tentative cost, which I told, around 2,000 rupees. That's why we call the radical change in iron ore industry. In pelletization, because of the we have the high LOI, high blade numbers, we have our productivity of the pellet plant goes down. That's why once you go for the magnetite, your pelletization, if you are a 1 million ton plant for hematite, you can operate almost 1.3 to 1.5 million ton of magnetite. And once we have shown that if it is the magnetite and synthetic magnetite, hematite, the temperature profile we have established for different grades. And this is the empirical model which we have developed for the what is the size of the pellet you can able to produce if you know the how much growth height and how much kaolite present in the concentrate. Yeah, and we also calculating this is the residual LOI uh, in my theoretical model based on the kaolite and growth height. And we are now, because the future is the pelletization, we are developing the pellet pot grade test in a continuous pellet plant in my center so that it can be easily translated to commercial scale. And now the DRI, because the government recently we have taken the, because I am the committee member, we have taken the decision maximum DRI should go in gas base. The gas base already it is people are doing by the JSW and ArcelorMittal and JSPL. Already 9 plants, mid-dex plants are there. Now how to produce the syngas? Morning already the Coal India has told they are going to produce the syngas. Once you will syngas, you will utilize for reduction of DRI almost 50%. You can reduce the carbon. Okay. And now the basic, now the Minister of Steel has given the 2 private organizations to establish the pilot plant of the DRI, and also IMT is also setting up the DRI plant based on the gas, because IMT already has put up the coal gasification plant. That syngas will be utilized for DRI purpose. Yeah. Now the another thought process how to reduce the energy. The direct hot pellet, you can use the DRI. Direct hot DRI, you can go for the smelting. The overall around 30 to 40% energy you can reduce, so that decarbonation can be reduced. Okay. My conclusion is the mineralogical composition of iron ore impacts in beneficiation, pelletization, sintering, and DRI process. To utilize the low and lean grade ore is a need of hour for sustainability of the iron ore as well as the environment through advanced physical beneficiation reduction roasting. To reduce the carbon emission, to meet the commitment, green hydrogen is to be used as a reductant for DRI production. Indigenous vertical technology should be developed for production of DRI to compete with the international. Thank you. Now I'll request to Mr. Bibhu Mishra. He, he was started his career in Nalco, then he has gone to Balco and different foreign companies. Finally, he was in the Hindalco as a president of R&D center, and now he is the advisor to the Hindalco. He has a lot of experience, particularly the technology related. We have heard his many lectures in different places. He, he will tell about the non-ferrous, particularly aluminum and its value addition. He will tell. Now, Mr. Mishra, you can deliver.
Hello, good afternoon. I think, for many of you, it will be a slight diversion, compared to what you have heard so far. I will take to a little bit a different area. Is it? I'll be taking to a different area. We'll be talking about aluminum and in aluminum production, what are the major challenges. So when we go for this, uh, just I will talk about a little bit about aluminum, its uniqueness, what are the markets, aluminum industry in India, its challenges, particularly environment related challenges, and lot of government schemes and all which are going to help the aluminum industry. So we'll be talking all about that, a little bit of that, but I'll prefer that if you are not familiar with aluminum, we want to stop and ask something, ask straight away. I'm okay if I don't finish the presentation, but if you've got something, just ask. So aluminum, it is a metal for the future. It is, in a way, it is in Earth's crust, it is 8% by weight, and it is the third most abundant element in Earth's crust. The problem was that it has got such a good affinity with oxygen that it took a very, very long time to find the metal and then subsequent its use. But it's now, because of its high strength to weight ratio, it is used in many constructions. Its resistance to many chemical reactions and corrosions, that is helping us. Its use in many construction and other areas. It has got good thermal conductivity, and it has also got a very good impact absorption and high elasticity. So that is also helping. The beauty of the metal is that it is 100% recyclable. So all the metal which is produced so far, it is estimated that almost 90% of that is still available, and it can be used. And of course now people have become much more smart. They know how to recycle much more efficiently. So the collection and use, it has become very very efficient. I'll give you one example in Kerala, where people use make their houses. They make instead of the steel seats, they put the steel corrugated sheet. They put aluminum, because they know that after 20 years, if they want to take that aluminum and give it for recycling, they will get more value. Means it is like an investment. If you put a steel with zinc coating, the zinc coating will be corroded and it is gone, and the steel will fetch you almost nothing. So in many other applications, people do more or less similar things. So the beauty of this is that India has got almost 5% of the world reserve in bauxite. Okay, it is, I'm sure that many of you may not be familiar. So I've just given a flow sheet. If you start from the top, it is the bauxite mining. Okay, so after the bauxite mining is extremely easy. Like if you have done other mining and all, it is extremely easy. And after that, the bauxite is just remove the overburden, take everything what you get. Okay, then you do a alumina refining. So that is the phase where you take all the impurities out and you just make alumina, which is Al2O3. And when you make that one, then that goes to a smelter where goes through an electrolysis process. So in the electrolysis, out of that Al2O3, you separate the Al and oxygen. Oxygen reacts with carbon dioxide, and carbon goes out, and that aluminum remains as a pure metal. Then it goes, of course, for the downstreams, and there are many various products and all. Now, a bit about the market scenario. The global production of primary aluminum is almost, it is growing at a rate of almost 6.66%, which is a very, very healthy growth if you think globally. Okay, with scrap, more and more scrap is being used. So now with scrap, it is almost 8.35% growth, which is happening. So as a market, it is around 180 it $1 billion in 2022. Out of that, India's market share is around 11 billion. Okay, and it is supposed to grow to around 20 billion. One thing which bothers me a bit is that if you see the per capita in consumption, aluminum is very low. It is 2. Global average is 9. Western countries are around 25. Even China, with which we compare everything, they are sitting at around 17. So we have got a long way to go. But also sometimes, if you think a bit deeply, you will find that though China it is 17, the local people, they are not using it. It is all getting exported to the other countries. Okay, whereas this 2 in India is almost used in India. We don't do too much of export. We'll come to those numbers a little bit later. Now like you talked about the steel, uh, India is also second largest aluminum producer next to China. But again, the ratio is as skewed as steel. Okay, here China produces around we produce around 4 million ton, they produce around 40. So almost 1 to 10. Steel also almost same ratio. Yeah. So we have got a long way to go there. But as an economic thing, it is next to steel. In the aluminum industry is quite big. It is next to steel. It is quite important. Uh, India has got many primary aluminum smelters. They are in Orissa, Chhattisgarh, Uttar Pradesh, Madhya Pradesh, and the capacity right now is around 4.13 million ton. If we go to the company-wise, Nalco is around 0.646 million ton. Hindalco is 1.35 million ton, and the largest is Vedant, 2.32 million ton. And Hindalco, to which of course I belong to. So Hindalco, what it does, it focuses a lot on also downstream production, whereas others, they go for just the primary production and then they sell it. I think there is a question. No? Okay. Yeah. Okay. Now, Hindalco is the largest. So after you make the aluminum, so most of that goes to either rolling mills or extrusion. So rolling wise, Hindalco is the largest. They are the number one flat rolled producers in the country, and Jindal Aluminium is the largest extruder. Okay. Of course, if we go to the downstream, the industries are scattered throughout the country. They do lot of things. In fact, it is really vibrant with, uh, you know, scrap melting to taking primary and all. They are extremely active group and they are doing a lot of great thing. One of the beauty of the whole business is that India does almost 1.22 million ton of aluminum scrap import, which is a very, very low value product. So that comes to the country. So we produce around 4 million ton and we consume 4 million ton. So that if you see as a country, we buy that 1.5 to 2 million ton of scrap, but we sell or we export a similar quantity of metal as a high value product, which is at least in the billet, slab, or downstream, or ingots, or the downstream products, and that is where we get a lot of value. Some of the very, very highly quality conscious countries like Japan, Korea, USA, they all take the metal from our country. Okay. Now, let us look at a bit on the prospects of aluminum in India. So, what are the growth which are coming up in this business? If you see Hindalco now, it is increasing its smelting capacity. It is building a alumina plant and also which is the refinery, and also on the downstream it is building flat rolled products, and all these things are mostly happening in Orissa. So for Hindalco, Orissa is one of the important place where it is doing a lot of business. In fact, for all the three primary aluminum producer, Orissa is like a base. And that's why when we talk about aluminum, we say that like Orissa is the aluminum capital of the, or aluminum state for the country. Vedant has got around 2 million ton capacity. The plant in Balco, Jharsuguda, in Balco, Korba, uh, they are coming with a very, very high current electrolysis process, which will be using a 500 kiloampere technology. That will be the highest kiloampere. Means more electricity, you do faster electrolysis. Okay, so that way, right now the Hindalco plants, they use around 360 kiloampere current, and they are the highest in the country. In China, they have got 500, but most of the plants are between 300 to around 300. So we have got, okay, but now we are going for 500. That will be the latest. Okay. Now, again, Adani Group, uh, okay, they are coming with a mine, and then they are coming with a refinery where they will produce around 4 million ton of alumina. So those areas are all like these are all very concrete plan, and obviously when they produce the alumina, ultimately they will go for a aluminium smelter, and that may also most likely come in Orissa. Now MCL, they have also, it comes in the paper from time to time that they want to build a alumina refinery because they have got so much of coal, and from coal they produce power, and aluminium smelters, they need huge amount of power. For a ton of aluminium, if you see the costing, almost 50% of that comes from the power cost. So sometimes you will find that, the aluminium product, the importance which we give to aluminium production and the related controls and all, the similar importance is put also on the power plants. Okay, so okay, now on the downstream expansions. So at one time, many of the downstream players who started very small, buying small plants from China, now they are also having a big mega trend. They are getting a lot of European equipments, slowly moving towards high quality products, and they see that maybe India is like a stepping stone, but they want to conquer the global market, which is also a very, very healthy trend for us. Now, aluminium, it is a very good multiplier in job creation. Almost for each ton of 1 million ton of aluminium, you can have almost 2 lakh jobs all around it. Okay. Now, okay, uh, the other thing is that aluminium contributes to almost 2% of the country's GDP, whereas steel does 12% and cement 9%. So it is quite important. And of course, I'm not. If you see the global, just 1 minute diversion from this. If you see the global economic growth, Western countries are not growing very fast, including USA. China, which was growing at almost a 6 to 7%, now it is close to 4.5 type of growth. So only the big economy, India, is growing at a rate of 7%, and it is expected to do so. So when when India's economy is growing at a 7% rate, the conservative estimation will be that aluminium is also going to grow at almost 7% rate. So now I have shown you some of the growth, the growth about which we know, but that is not adding up to 7%. So a lot more things are going to happen, which we don't know now, but definitely these are going to affect the GDP and the economy of the country. Aluminum is also one key contributor to Make in India initiatives, and uh, it is used also quite a lot in high-rising building. when you build in Bombay, Delhi, and even in Bhubaneswar now, you've got 20 to 30 floor buildings. So when you build the height, you want it to be light. That means the builder tries to put as much aluminum as possible. So that is how in the building construction aluminum is used. All the electrical vehicles, they use aluminum because it is light and it will give them more mileage. And also the bottom part of the cars, EV cars, where it is all battery, it is a single unit. That whole floor is a single unit. Inside that you have the batteries. It's all covered with aluminum, and in between you have the ducts, hydraulic pipes, or whatsoever you talk about. It's all inside one monolithic thing that forms the bottom. So that is made from aluminum. We have just commissioned a plant uh, which is producing mainly for Mahindra, and those vehicles are yet to hit the market. So that whole thing is manufactured only with robots. You see the plant, you don't see any people. It's all robotics, huge robotics, and they are doing all the welding. Uh, and that is only the bottom part of that vehicle, EV vehicle. So EV vehicle is a big thing. And the other big thing where aluminum is coming is the solar panels. Okay, so solar panels also they are using, and because we see that there is a lot of bauxite in the eastern part and especially in Orissa, and so the aluminum production is happening here. A lot of power also is produced here, so we see that lot of growth is going to happen here, and that is going to help the economy. Only thing which bothers me also sometimes is that the downstream, where there is a lot of value addition, there is a lot of job opportunities and all, that is not happening much in Orissa. So as Hindalco, we are also trying to talk to many local entrepreneurs, encouraging them to build the factories here. Because we have seen in western part of the country, north and all, south, lot of things are happening. East, it is not happening. The downstream is not happening. So aluminum is, okay, I talked about that. Okay, now let us talk about some of the major challenges. So as you can see from the graph, this is the price of aluminum. It is controlled by London Metal Exchange. So it is a price which is known to everyone and is a very, very transparent price. And that way, all the smelters or all aluminum producers in the world, they are like doing one competition and they are a part of that. And you can see there are very, very long cycles. And now the price is around $2,600, and which is a very comfortable position. And that is where also a lot of expansion happens. But sometimes you will see below 2000, it is a very, very questionable phase. A lot of businesses, they don't make enough money to go for the expansion. So the challenges are that when we come to the eastern part, still uh, we have got the problem of infrastructure. Now Nalco, Vedant and all, we are making all alumina almost in the same area. There is not enough railway network to take that alumina to different plants. So, what you do, you buy more and more wagons, but the railway line is getting clogged. So cheap power and renewable energy adoption, these are also challenges. Many European and other customers, they want green aluminum. That means they want that the power which is used for making aluminum must come from a green source. It can't come from coal. So that is a challenge for India, because in India we produce most of our power from coal. Now, there are a lot of regulatory changes also that comes because quite often aluminum is like still a lot misunderstood. There is only one way you can do the electrolysis, and that is almost 125, 130-year-old process of electrolysis. And there we use something for the electrode. It's called calcined petroleum coke. Suddenly somebody went, spoke something, and then Supreme Court told that it can't be used. Okay. Then we told that that means the whole aluminum industry has to stop in the country. Then after that, they understood and all, it's like, those, anyway, I'll not talk all those things, may not be appropriate here, but finally we manage to, uh, you know, manage to get the CP coke, but not a healthy situation. So that misunderstanding and regulatory changes that affects us. Uh, there are, when you are making aluminum, also there are a lot of hazardous waste they are getting generated. So how to manage that, that is also a big challenge. Aluminum takes a lot of energy for production, but when you do recycling, the energy requirement is very, very low. It is only 5%. So there, aluminum industry has to say that lifetime cost of the aluminum is good and it's a green metal. That is where still we are not able to communicate that very well to the rest of the world. Here I will show you a sustainability challenge related thing. Uh, okay, so here you will see that when you do the bauxite mining and then you go to the alumina refining, there you produce something called bauxite residue. So suppose you take 3 tons of uh, bauxite, then you produce around 1 ton of alumina, and almost 2 tons of bauxite residue or red mud is produced. Then when you go to the aluminium smelting, there you need to use the power, and when you use the power, you generate some carbon dioxide. So there, if you see, okay, so that is also one of the things, key thing. And when you go to the downstream, then you produce this dross and other material. Now, in this whole thing, if you see, on an average, aluminum produces around 13 to 18, uh, around 12 tons of carbon dioxide per ton of aluminum. But the guys who are using coal, they use around 18. They generate around 18 tons of carbon dioxide. Those who are using natural gas, they generate around 10 tons. And those who use pure hydroelectricity, they do around 6. So there is a caste system you can see. You know, the guys who are producing, like China and India, they are the dirty aluminum producers, though the metal is all same color. Okay. Uh, but you know, some people are blessed with the hydroelectricity and we don't have now. So that is, anyway, that is a challenge we need to overcome that. Okay. In fact, there is a there is an index. It's called Dow Jones Sustainability Index. So this index is used across all industries. So it is used for aluminum, steel, cement, all the industries. And in that, they don't look only at 1 or 2 parameters. They don't look at only carbon dioxide. They look holistically. Like, is your company transparent? If are you training and you are treating your people well? Do you have diversity? So they look at hundreds of parameters to see whether how the business is sustainable. And in those things, in those holistic things, Hindalco is consistently coming as a #1 sustainable company in making aluminum globally. That means our competitors, European competitors like Hydro, Alcoa, Alcan, so they are far behind us. And in fact, we have seen some of their plants, and also holistically, if you see, still we are a leader as a holistical producer of the aluminum. But when it comes to the rules and regulations, when you go to the line by line, some of the places we are not up to the best. Okay, so these are some of the challenges, but still, you know, with a lot of government of India's schemes, the aluminum industry is taking the benefit. With the Make in India initiative, that is giving us, you know, a big impetus to manufacturing. The PLI scheme, even Hindalco is participating in some of those uh, PLI schemes. So so there, especially for the solar modules and electrical vehicles, so those areas you can get the benefit. Ease of doing business. I think many industries who are in Orissa and all, I think they have experienced it. We aluminum industry is a beneficiary of this. The national single window system, that is also helping. The industrial corridor development program, that's also still a lot more is expected in terms of logistics and all, but still these are also helping the aluminum industry. So that is more or less, I think I have finished my time. Okay. Okay, okay, this is a lot more technical detail on how to decarbonize the industry and having the MSME, aluminum parks and ancillary. I spoke a little bit about this. So that's all about, my presentation. Thank you very much.
Thank you. Now the next speaker is Dr. P.K. Banerjee, outstanding scientist of CSR Simper. Okay. Yes. Any questions from the audience? Yeah, please.
What is happening is that you have so many byproducts. I don't say waste. You have so many byproducts that has value. Red mud. Technology is established. It can go to the cement plant and grinding units can take it up. Geolite is a product which comes in the refinery. If geolite is taken up in the country, all the detergents which we are making, they will be, phosphate will be removed on our wetlands and water bodies will be all clean. Geolites can be utilized. There is a price comparison, but government always, when government can give penalty to farmers for burning the stubble, then government can also give penalty to the detergent companies to go out of phosphate base and use geolite. And you can give free or whatever is there. That is true. Why it is not coming? You are having so many profits. One or two more. One or two more. Coming to the smelter system. The pilot studies have already proven 16, 17 years back that spent pot line can go easily as a fuel material for the cement kilns. Fortunately, we have a lot of cement kilns here. Your cyanide also can be broken into carbon and nitrogen at 14 degrees centigrade, and spent pot line, I think Biswal will tell, its energy is something like 4,000. Energy value is very good. So coal also can be reduced. That is again a problem. If the technology is there and companies are there, why you people not having relation that they should buy it and you should use it, you should give it to them. You means I am talking about all aluminum sector. Lastly, fluoride is a issue. Whether you don't show it, but it is an issue. And farmers and the cattle, they are getting affected through the fluoride. FGD is not properly maintained and FGDs are not there also. So in the ambient, fluoride is already there. If there is any alternate technology or there is something that we can reduce the fluoride or you can remove as a catalyst and something else can be used, then only we will become green. As on date, Odisha will be having problem if we go on having more and more aluminum industry, unless you see that these materials which are becoming a burden to the society, they are utilized and really some benefit from those waste is generated. Thank you.
Thank you for the questions. Okay, first I will start with the red mud. I talked about that 1 ton of alumina, when you produce it, we generate around 2 tons of red mud. And in fact, when I was first time going to our plant in Belgavi, there was a new driver, and when I told him about the plant, he couldn't find it. He couldn't tell me exactly where it is. So I looked at the Google map, then I saw a very red spot. I told, okay, let us go to that place. So I marked that place. We went and we were next to the plant. Okay. So, and in fact, red mud is a global problem. Many people have done a lot of work, and I was the chief operating officer. Like I was taking care of all the manufacturing of Hindalco before my retire, taking this advisor role. Uh, at that time, what we did, I can tell. I will not talk about the other plants, but I can talk about what Hindalco is doing, and in fact, these are also related to the that Dow Jones Sustainability Index, which I talked about. What we started doing is that we got the cement experts. Okay, for you know, all our Hindalco's red mud is completely 100% is used in the cement industry, and even the some of the historic, the past accumulated red mud that has also already been used. Only Utkal Alumina is a plant. So we have got 4 plants. Out of that, 3 plants it's all 100% used. Utkal Alumina is one place where we are having still problems because there are no cement plants nearby. Cement plants, so first thing is that developing the technology. We got a uh, you know one of the technology experts in cement plant, and we worked with him for a very long time, more than 6-8 months, doing a lot of raw material analysis and trying to see from the plant point of view how much red mud they can use. And then we realized that whole India, you have, because of the type of raw material available for cement plants in the south, okay, red mud we are selling. Okay, we are getting a small amount of money when we give our red mud to the plants. Whereas north and the east, it was not known how the red mud can be used. So we co-developed those things with the cement plants, and now they are happy to take it. Only thing is that they asked us some money. That per ton you give us this much of money. We are giving them. So now they are taking. Now, if somebody is not giving, then it is their plant, their business. I've got no comment. I've worked in all 3 primary aluminum smelters, Nalco, Vedanta, and Hindalco. Okay, but I can talk right now for Hindalco. Okay, now coming to okay, so that is the red mud thing. Now coming to the SPL. Yeah, just okay. PK, you were also a part of that, no? That development of the, you can hear, no? No? Okay. Yeah, PK Banerjee was the chief technology officer at that time.
Yeah.
Okay. And he was one of the key persons in developing this, what I'm telling now. Now coming to the spent pot lining. So spent pot lining, it was more like the rigidity of the pollution control boards all across, which was creating problem. Otherwise, calorific value is all right. We know that if you put in a kiln, the kiln temperature is definitely more than 500 degrees centigrade. So that cyanide will break. But, you know, hundreds of, when I was the chief operating officer of Balco, we tried for 2 years. Everything happened when but the reports will not be accepted and all. So finally, we used to accumulate. But now those things have changed. Balco is doing that. They are sending to the kilns. Hindalco, all the plants we are sending, the SPLs we are selling to the kilns. It has got, I think, more than close to 8,000. Means it is as good as a very, very high quality coal. The historic, the accumulated ones, even from companies like Alcan. Alcan's company, which we bought, they had the accumulated SPL which we have finished. About the fluorine, there is only one process, that is, uh, cryolite, in which alumina dissolves, and then you can do the electrolysis. And cryolite has got fluorine and it is going to evaporate. So fluorine, there is no non-fluorine process for making aluminium. Now the best thing is that how to make the aluminium. So how to efficiently use, we will talk about that. I think
Okay, thank
otherwise
you.
we will.
Now, yeah, this is the fluoride. Now what they are doing, the fresh alumina, they are fluidized bed, they are recirculating. Around 85% of fluoride they are observing. Only 15% still it is going. More than 90%. They are doing it. Yeah. Dr. Banerjee, are able to hear? Okay. Yeah. Now, Dr. Banerjee, actually, after he got his BTech and PhD from IIT Kharagpur, he joined Tata Steel R&D. For long, he was the head of the raw material divisions. Then he has gone to Hindalco as a CTO. After Hindalco, he joined as an outstanding scientist or Simper CSIR laboratory. At present, he is working as the head of Simper. Now, Dr. Banerjee. Where is he now? Yeah. Yeah. Yes. You go ahead.
But only thing is that when we talk about coking coal, we have to read the problem with that. We have less coking coal, and that quality is issue. And because of the demand supply gap, almost 20% of the coal today is imported. Now, what's coal to continue as key driver for the nation? industry is facing many challenges. What are those challenges? Of course, the politics and they want finance. And beneficiation is extremely difficult. The possibility that this is very, very difficult kind of thing. And of course, for itself is something associated with the emissions of climate change impacts to CO2 generation. So that is always a big issue when you go to. And only that, so this generated from again to usage price is very, very high. Specifically for the steel industry, when you talk about challenges the coal industry is facing, in order to provide the quality of coal demanded by the sector, almost 85% or more of that is getting imported today from the steel industry. And of course, I have difficulty not only for the company, even for commercial, the application, all these technologies are very heavy. Therefore, there is an issue with finance. So, in other words, industry has to address these challenges in a very, very sustainable manner. So, let's understand what is expected. What is expected from the consumers. The consumers, the whole consumers, obviously, the very often that consumers don't want to actually want. So whatever these steel companies, and when it comes to steel company, they need to quality coal and they have good quality coal as the input. Not only that, they do prefer to take domestic coal because of the price advantage. Unfortunately, because of the quality and all, the steel companies particularly is importing so much of coal from outside. Then the coal company is also getting challenged from alternate fuels because of the the climate change impact, global impact. The biomass is one potential alternative. So I think the best thing that coal company should look into is an opportunity how to get synergistic applications with the biomass. Not only that, coal can be converted into cleaner fuels, could be syngas, could be hydrogen, could be methanol. So those are kind of like cleaner fuels can be converted from coal and utilized. And of course, since in US, the coal, the carbon capture, utilization, and storage solution has to be part of the coal usage process. It is an integral part, and if it is done, possibly many of the challenges could be overcome. And finally, the waste which is getting generated from coal, like the fire and salt and the monomers and all those things, needs to be converted to value-added products. So, in summary, if I say that decarbonization is the central theme of sustainability of these industries, and the coal industry has to be aligned with those expectations from or the steel company or other companies. So let's drill down into the coal and its applications so far as steel industry is concerned. But I think for the steel industry, coal has a very, very important role, very, very important position, I must say, because it is a commodity having impact in all the three sustainability parameters of pillars. We call it people, planet, and profit. Everywhere it has an impact, high level of impact. First of all, if you see the consumption, almost 800 kg coal is needed for 1 ton of steel, and that means almost 30-40% most of the food steel. So, cost wise, it is a very, very important component. In the environment, which I have already said that almost 2.2 to 2.5 tons of CO2 is emitted because of production of 1 ton of food steel. That means almost in India, 1% of CO2 emission is coming from the steel industries, and globally it is 78%, which is very high number. And of course, aspiration is very high, steel company is growing, and it will be 20, by 2030, we have an expectation of 300 million tons, which is not going to happen, but it is going to happen in another 5 years. Maybe by 2035, and that time, if you look into the consumptions of coal, again, that's a very huge number. Almost 300 million tons will be needed. So where can we get that? So that is where we have to get some solutions. And particularly, I was talking about the quality of coal. You should see that ash is one parameter is extremely important. If the ash in coal element is high, it means the coal grade is high, the blast furnace productivity is low, operating quality is poor, and of course, emission will increase. So therefore, in any case, has to be brought down if at all the steel companies has to be competitive. Our domestic will have to be used, then our whole has to come down. And that's why we have in a very a realistic target for domestic coal, if it is lost to 80% and below, it can very well be blended with partly imported coal because we can't totally eliminate imported coal. So it will be rate of 8 to 10%. So we can still blend our captive coal. Maybe the aspiration is up to 25% of our imported of our crude coal should be coming from the Indian sources. So that's a target we have made. And not only in terms of coal making, there is a power coal is being injected in blast furnace called PCI coal. Now this coal is non-coking coal and the ash is below 10%. Now 100% of PCI coal is very important. Okay? So again, there will be some opportunity to look how to substitute this imported PCI coal with domestic. Uh, and coming to the third application with mineral plants, we are also looking gold, and which is roughly 20 to 25% as gold. So why not looking gold was to that level so that again we can reduce the imports. So in other words, simply is what is the challenge which these two companies have to address. Number one is that bring on the acid coal, beneficiary coal. Then the number two target is to implement technologies along with both methods, the full company has to work and find technology which can accommodate more of our goal. And of course, the third objective, which is the main objective, convert coal into cleaner fuels, to be syngas, to be hydrogen, to be carbon. So with that, let me now take you through some of the opportunities where we can, address those challenges that we face. So coming with the first one, the called beneficiation. Now, on beneficiation front, just see the numbers. We have coking coal in the country which is mined daily 60 million tons. But hardly anything is produced. Less than 5 million tons of phosphorus is produced today. So that's very small number. And even our target, 140 million tons of coking coal will be produced by 2030 and that will be also to produce 56 million tons of phosphorus by 2030. I must say that we are nowhere close to that. So we have to do a lot of actions to go closer to those numbers. And the first thing which I am telling is the existing water grids. There are huge opportunities in the water grids because they are running, not optimum level. The enemy is low, ash is high. So I think there are what can be done with the existing water grids to improve their performance. Of course, the water grid has their problem. They are not getting the coal, not getting the right kind of coals of quality. Quality is cheating like anything. So there are issues. They are old plants. They are cheap lost their technological life. There are problems with the fine techniques. They do not have adequate fine treatment facilities. So there are issues there in this industries. And possibly this could be one area where we can actually get into and bring some improvement. Maybe should be in terms of working those will be available from existing washeries in the washing performance system. Then the second opportunity is the local chemicals which is there in Chia grocery or Bharat grocery. These are the people activity lower seems very mature coal and that's a low gain. And today, most of this coal, which is 50% of the cooking coal reserves, whatever we call cooking coal reserves, half is the MPC coal. Now, a lot of them will not at CSA, laboratories, and special silver and not. And it has been established that if we beneficiate this coal, because this coal is additional to beneficiate, so we will expect a very high level of yield. We can produce 17% as we will get 20 to 25% yield, which is enough, which is quite a significant number. And if we can get that, we will be available for the land for the steel industries. So these are the opportunities, and already the companies have started taking action on these. They are using the LPC coal. They are adding this stock coal into the washeries, but possibly we can think of very dedicated washery because this coal is difficult to wash and it has its own process sourcing. Possibly more dedicated washeries are needed to treat LPC coals to take a portion of this coal as the coking coal. And the properties, if you see on the right side, that's a very improvement after washing. So from thermal coal, basically it used as a thermal coal. So the clean coal is showing coking properties and could be treated as a medium for people to the full base. So this is another option areas for the whole companies. Let's now look into the third category, the non people. Not yeah, I'm not talking now coking coal, talking non-coking coal, and the non-coking coal, which is used as a PCI coal in class 1 is that is the unit pay, and 100% is imported today, almost 7 million tons. So now, not what being done by Switzerland about these IMT, NIH, steel companies. So they have done a significant amount of work and finally concluded that very well selectivity has to be done, identify certain mines which are of the lower tax. The rock pool itself is lower tax, 27, 28% tax. If those mines are identified and selectively go for washing, they can produce 10% as product, non-coking product, maybe 30-40% yield, which is very good yield, and that can actually go into the blast furnace for injection. I think that's a huge opportunity, and I'm sure this is the areas to be looked into. Even they evaluated a payback period which is 2 to 3 years, which is very, very attractive. So I think this is another opportunity how to replace the imported PCI code with the domestic non-coking coal was 10%. And finally, there is another opportunity for BRT plant. I was talking about BRT plant, which is not today 15 million tons. With 37 million tons, BRT is produced of coal, which needs 45 million tons of coal. So that means 45 million tons coal is used by the BRT. And half of that, more than half of that is today is imported with 20-22% as. I'm sure, this level of coal can very well be produced from that is the inputs to washing. This is suitable. And there is a reason, why COVID coals are being used here. Primarily because of the consumption is there, the CO2 impact, the footprint is also quite low, as you see the numbers here. 1.5 to 1.6 for imported coal, whereas for Indian coal is 1.8 to 1.9, quite significantly higher. So I think there are a lot of benefits from even environment point of view, economic point of view, and if we can watch among the people to handle and deliver tremendous numbers to the plants. Okay, so with that on the coal front, let's look at the next bigger industry, the coal to coal, the carbonization. Now, not only coal needs to be improved, but in the carbonization of coal making technology has to be also improved. How they can accommodate really lesser cooking properties for or non-cooking coal. All coals can be accommodated to make it good. Now, when the technology which has emerged recently and which we use, which is talking about non-recovery facility technology. Now, standard non-recovery technology is more popular today, and this is a technology where CSS has worked for several years, fine-tuned and developed technology, and today this technology, when it was leading non-recovery technology commercialized. This technology has been commercialized at Google and more company, and they are working plans is taking this technology to produce 1.18 million tons of coal. So this is advantage because this technology can accommodate meter pools, meter cooking pools, or even more medium pools with some non-cooking pools. This technology can always accommodate. But what we are targeting, no non-cooking coal whether it can be accommodated because that's what we have in our country. So we have come up with an idea which is still at the bench scale level. It's called hot stand. So not only stand can be done at hot condition, hot stamping conditions. So that will give a lot of advantage and you can use a lot of non-cooking coal into the plant. If you see the results here, this is the process basically a preheating and a hot stamping and it goes for the cook making. And because of this hot stamping, the bulk density improves, the plasticity improves, and therefore it can accommodate many a lot of non-cooking coals. And the study is shown, and the right side you see the plots here. You can pick up any of the color. Just to familiarize cooking when we are moving to top to sanchez to hot stamping. If we are seeing that on the right side, if you see any of the color box, see it is increasing. That means the state is improving. So this is very, very good kind of observations. And in the laboratory, almost 40% non-cooking coal can be accommodated in this outstanding. So we are going to experience scale up this technology and go for piloting. This is in the process of piloting because there are other issues associated or outstanding, maybe safety issues, environmental issues, operational issues. So those issues to be addressed. And hopefully this technology fix then it will give a lot of advantage for coke making country to get good coke from weaker quality coals. Now let's go to the next one, the gasifications, which I said on a long term, coal has to convert it to energy. That's the need. The need what is talking about handling basically making and all. So all this direction is achievable even starting from coal. We don't need to have starting from electrolyzer with the green electricity, no such one. Renewable possibly that much of hydrogen may not be cheaper compared to coal. We have coal. So what we need a technology basically to convert coal to hydrogen is nothing gas or even hydrogen in the long run. Now again, this is the space where a lot of work being done at Sigma. We are last 2 decades we are trying to use these technologies. On the gasification, there are technology, there are commercial technologies that are available. But the problem is that with Indian goods, there are difficulties because of high gain. These technologies, whether fixed rate technology or the different rate technology, gasification technology, they mix lower as good. So either you beneficiate and benefit into the gasifier, or you look for a gasification technology which can be high population. So Simple is working on that, which can accommodate high agreement code. And the technology has been taken with the pilot level 1.5 PPT grown pressurized fluidized bed gasified technology, which is now running, which can go up to soon after 45% mass in the gasified and product gas, the C gas is quite rich in hydrogen and monoxide, CO 25%, 30%. So this is the lost gas which is coming out of this gasifier. And of course, there are multiple states. We can do what basic reactions to enhance the hydrogen content, and then we can separate the CO2 and enrich further the hydrogen again. And finally, to membrane separation, the hydrogen can be taken out and bring it to the hydrogen as a product. On the right side, let's osmosis being proposed. That means slightly for washing, gasification, and then making the syngas. That syngas itself can be used as a clean gas for many applications. Could be power, could be in a blast furnace, or definitely for the DRL plant. Straight can be used. It can be enriched by water gastric reaction and CCUS to have hydrogen-rich syngas. That would be even better. And finally, if we can be hydrogen out, then hydrogen will be pure or
Dr. Banerjee. Hello.
So, hello.
Dr. Banerjee, within 2-3 minutes, please conclude.
Yeah, so I just come to almost end. What I'm talking about that for hydrogen separation, membrane is not where we are working, and membrane development is an area. I'm not getting into those details because that's make the economic, that's make the process value. So we are working on that membrane part. And of course, I just rough, number I just showing you. So to complete, if you see, there's two scenarios as comparing. One is coal to hydrogen or coal to electricity, and the electricity of hydrogen and the energy abundant. And it's basically not with the hydrogen, you can take both them as the equivalent energy. Then possibly, this hydrogen route from coal is definitely better than the other one. So I'm not again comparing those numbers. We have the issues of CO2 different component of entire process, and if the system is effective, then definitely the carbon footprint will come down significantly. And finally, this is the T-shaped roadmap. I'm not getting the details. What I'm talking about, we need to have the technology not only for capturing CO2 and then of course utilizations. The multiple utilization routes are shown here. Where you get separate patients, we can go to those details. And so, again, we are working in a number of areas, particularly enhanced to the billion recovery issue can be pumped into gold mines and the billion can be recovered and shipped and sequestered. That's a big area we are working. We are working on CO2 separations and then converting to manual chemicals. That's another area environmental works being done. So I think that that's from my side. Just to conclude, coal certainly going to play very, very important role for the growth of the nation to make it exceed Bharat. There are challenges, there are issues, particularly associated with climate change, and we need to work in those directions either by clinical technologies to beneficiate or convert into the cleaner fuels, gasifications, and those tools. I think that's from my side. If you have any questions, I'll be glad to answer. Thank you very much.
Thank you, Dr. Ranjit. It will take 5 minutes for the question. Okay, thank you. Hello. Yeah, please. Okay. And last question will make.
Thank you so much, Mr. Dr. Paswal, and all the speakers.
We are thank you for the organizing committee, the seminar, giving the chance to present paper and also share the session. Thank you.
Thank you, Dr. Biswal, and all the speakers. Now we are going to start for the technical session 2. The theme of the technical session 2 is sustainable development. And I would like to request Mr. Girija Prasad Mahapatra, the chairperson of this session, and the speakers, Mr. Vijay B.K. Sahu, Dr. B.M. Faruqi, and Vikas Mohanty to come over the stage.
Hello, hello. Sound okay?
Laptop.
Mr. Sahu is coming. Just hold on, sir. 1 second. Mr. Sahu, please come.
Now I request Mr. Girija Prasad Mahapatra, the chairperson of the session, to preside over the session.
Thank you. We are going ahead. I think Sujit has already told me that we are running very late. So nearly 35 minutes, I think. Sujit, have you calculated how much we are running late? 35 minutes. 45 minutes. So we can't conserve within that much of a moment. So we'll go ahead whatever the program is there. Thank you, sir. And today our speakers are B.K. Sahu from IBM Nagpur, retired. Dr. B.M. Farooq, retired from Geological Survey of India, Marine. And Ajay Kumar Chaudhary, Nalco, GM. These are the three topics which are there. Without further delaying, we will start. Sir, I think today is the smallest day it seems the year. So we have to be very conservative in our timing so that the evening will not come so rapidly. So I think 1 hour will be not taking. We will be very strict to do that one. So 15 minutes is sufficient for you, sir? Sir, but we can afford only 15 minutes. Please, I think. While going, sir, I think please give a brief of yourself. That will be very fine of you. And Dr. Farooq, I think whatever I told, I don't have to repeat, sir. Okay, sir? And Mr. Chaudhary also. Sir, as early as possible, we can leave some part, I think 5-10 minutes for discussion. For other people, they can participate or whatever they like. So 15 minutes time is allotted to everybody, sir. We'll go ahead, sir. We'll go ahead with Mr. Sahu.
Good afternoon, everybody. This is the topic I would like to interact with the esteemed member and the participants. Basically, in Indian context, in economic perspective of the mining sectors is a identical things that would bring a systematic details about where we stand in the global scenario. As you know, this is not exaggerating. The mining industry has a significant part of the economy for many decades and plays a major role in the economics of many countries across the world. It is essential for industrial and economic development of the nation. And as a product of mining, various economically valuable products might be obtained, but that is coal, diamond, metallic, ores, oil, and so on. Minerals are used for large variety of purpose, either directly or processed into other products. Mining sector is pivotal to the world's economy. Numerous industries worldwide depend on the supply of mineral commodities from underground to open pit minings. As you know, the global mining industry output equal to 6.9% of the GDP of the worldwide, that is at the level of 5.9 trillion USD. Looking at the potential market size of the mining industry in the world economy, it is easily understandable the mining industry controls the growth of other industries such as energy production industry, chemical industry, electrical industry, and electronics industry. The results. Why I put up these results and finding, so that under this finding we can go ahead what we would like to address. The mining industry in India, as you know, it contains about the 2.2% to 2.5% only the GDP of the mining industries. In comparison to other developed countries, still we are well below of our potential. And the industrial sector, it contributes around 10% to 11%. The metal and mining market in India is estimated to be 179.23 billion dollar by 2025. This is the predictions has been made by various society, and it's concised. The India, by rough estimate, only 10% is explored obvious geological potential and less than 2% it mined. So if you see our estimate and our mind in comparison to our similar economies in the world like Australia, China and others, we are quite lagging behind them. The reserve and resource ratio, which was as per mineral exploration practice, should be over 50%, which woefully low for most of the minerals as we have seen in our Indian context. Then the economic impact of world mining. For example, the emerging economies are now major player in the production viability of key commodities such as copper 70%, bauxite 40%, with iron ore produces precious metals, leads and other within this range. Another key trend in the globalization and the dominance of the market economy with three important elements. That is, number one, the creation of global capital, goods and service markets, creation of global communication and information space, and emergence of the global values. This is the way the mining industry is impacting the economic scenario in the world. Before going to the details, I would like to elaborate about the economics aspects, particularly with respect to our mining industry. Particularly the economics around the globe struggles to gain momentum. The metal and mining sector awaits opportunity to capitalize on demand growth simulated by the energy transition. Weakening activities levels committed for exploration, as you know all. Our exploration and drilling activities retreated to a 3-year low. With many economics facing variable outlooks, metals and mining metals struggle to stay abreast of leading indicators throughout. Then mineral life cycle impacts. It is a parameter which affects the behavior of our mining sectors and its stance in overall levels in respect to the economics with respect to our mineral industry. It is imperative that the mineral life cycle impact assessments with regard to the depletion potential of mineral resource and reserve. The question has become sustainability of minerals reserves occurrence in the level of geological confidence. This creates the effect that reserve and resources sustainability is a function of factor that is mining, processing, metallurgical, supply, demand, government, legislation, etc. Consideration of modifying factors that depicted as under. You can see the increasing level of geological knowledge and confidence and exploration result the way we have, and how it is connected with different level of mineral resources and mineral reserves. Metal demand with economic cycle. The GDP or the gross national product is not constantly growing. It generally has a cyclical trend which long-term growth trend as depicted below. It is evident from the system that how the technospheres at various level is attributed by the various factors and the drivers, particularly demands, politics and governance, discovery technology, extraction technology, access to energy, cost of capital and exchange rate. This is the primary drivers which affects to our technospheres with respect to the mineral economics. The accuracy or the variability of the factor differs in technospheres reserve, resources and the yet to be identified deposits, which is explicit in the earlier page with sequence wise. In the metal demand with economical cycle, you can see the real GNP and long-term trend and years. How the boom and then recession, then upturn and the capacity production affected as explained in the earlier slide. And how the price changes with demand in economic cycles. The distance between the GNP line and the capacity of production provided a measures of availability. Market demand directly affects reported mineral reserves. Raw material prices are directly impacted by the technological progress and less predictable, which don't lend themselves well to the characterization as shown in the earlier slide. There is increased pressure for metals and minerals to meet the demands of estimated 6% growth in GDP with respect to metals and minerals. And in our mining sector, the objective that is a pivotal for the world's economy, and numerous industries are depending upon commodities from the mines, and the global mining industry output percentage of GDP worldwide is US $5.9 trillion. You can see the amount we have in the worldwide. The dependency of various high-tech industries on rare earth is a recent issue. Coal, on the other hand, is still one of the leading global energy resources. The global mining market grew from US $2022.6 billion in 2022 to US $2,145.15 billion in 2023. The figure is up to July 23, as compound annual growth rate is 6.1% only. The mining market is expected to grow from 2,770.5 billion US dollar by 2027 at a glance, CAGR is 6.7%. So you can see the potential of the mining market with respect to the GDP from mining in India increased from 981.4 billion rupees in the first quarter of 2023 from 790.22 billion rupees in the fourth quarter of 2022. So India has a world's fourth largest natural resources with mining sector contributing 11% to the country's industrial GDP and 22.5% of the total GDP up to the country. So contribution rank of the India in world productions and different minerals. For coal and lignite, it is the India rank is second. Bauxite 6%. India rank is third. Iron ore 8, and India's rank is fourth. Manganese 5%, and the India's rank is 7. And if you can see the sufficiency, self-sufficiency with respect to the chromite and iron ore and bauxite, it is 100%. In context of our country, which is a blessings to our mineral resources with respect to our industry. Similarly, magnesite, apatite, rock phosphate, metal and aluminum are in various orders, which give the glimpse of our various minerals with respect to the world scenario. Then another aspect for our mineral resource development cycle, in the figure it is the various cycle and its development is essentially categorized. And particularly if you see the availability of land resources, then exploration duration period varies, then environmental assessment and approval and ongoing stakeholder consultations, then constructions, then operation, then closure and reclamation. If you see these cycles, we have to maintain for exploitation of the mine, minerals, and up to the reclamation stage. This is the context. It is not only in our case, particularly with respect to China, if you will see, they are much ahead of us. And if I can see some of the mines in Indonesia, in fact, they are much ahead of this cycle period with respect to India. That is a very encouraging thing in case of Indonesia. Then another aspect, as you know, for the mine, various labors, activities, and government revenue is a part of the contributing factors. Acha. This is the mine life cycle versus labor activities and government revenue. In different time scale, how it is varies the various years it is depicted. Then contribution to GDP mining sector in India and various period wise, quarter and year wise. Since the time is limited, I'm going through the pictures so that it is less time to explain the things, but it is categorically explicit in the diagram itself. This values of the production in Indian iron ore cores for various metallic minerals, non-metallic minerals, and what is the production level, and mineral export in countries in billion in various countries, and this is the way for the various countries. Then GDP of mineral produced by various countries. In India, we have got in 21.7, whereas China, you can see 2017.8. So our ranking with context to the mineral resource and reserve is we need to be more competitive. Similarly, production, import and export of major minerals has been there, various figures. Challenges faced by the mineral sectors, this is the things it is well aware of. There is high capital intensive, operating cost is high due to energy, fuel and various consumable. Private players comprehensive to infuse huge capital due to high risk. And these are the factor: high tax rate, regulatory issues, availability of environmental issues, social license to operate. These are the aspects. Way forward for the perspective, boosting exploration. And if you can see, the obvious geological potential is need to be enhanced in a context of India. Then taxes and royalties rationalization. This is an aspect need to be addressed since in India in comparison to other mineral rich countries. The taxation rate in India is comparatively high, and it has to be addressed in the particular forum with various participation with the various stakeholders. And avenue for single windows, all these things, as you know, government is trying to cutting down the multiple application delays. This is a area where government is taking a lot of initiatives. And another, that taxation principle that comes into the factor, the way recently the Supreme Court judgment in respect of mineral taxation versus center and the states. And this is the principle which has been adopted to counter in the court. And ultimately the mineral sectors and the state particularly come out successful with his principle. And this is the way how the taxation principle should be read. This is the basis on which Supreme Court has been explained regarding this, what should be the economic rent in respect to the various taxation to the minerals. And it was convinced by the Supreme Court, on which the state government has got the benefited out of Supreme Court judgment. And as you know, I have explained royalty and all these things, how court has acted upon it, and how the state government has got a benefit of its resources in the state, and to get his due, since he was losing from 2006, for which he demanded from April 1st, 2005 to July 25, 2004. Stagger payment for 12 years starting from April 1st, 2006, it will be paid by the various mining lessees or the companies in respect of the, and the Supreme Court affirmed the states' authority to impose cess on mining land and quarries, while clarifying that royalty paid to the central government by the mining operator did not constitute a tax. It is in fact a landmark judgment by the Supreme Court, and it is also a winning for the state from where the minerals resources are occurring. And these are all the details of the various stakes, how different companies owes and various states will gain. State-wise royalty acquired from major minerals from 2017 to 2020, this is the things, it is calculated how the state government will receive all those things in the from 2006 in a phase-wise. Sustainable goal, as you know, it is a part of the minerals resources, and it has a prime importance for sustainability. And for this mining sustainability development, this sustainable development goal has been developed by United Nations Development Program, and environmental aspects has been addressed to these factors. Thank you.
Thank you very much, Shavu. I think you have presented very nicely here. I think there may be some questions, but now we don't have time. I will request Dr. Farooq. Farooq sir, to present your subject with a introduction by you, self-introduction. Sir, I know very much, but others may be knowing. Marine minerals in India, prospects and challenge.
Thank you, Mr. Mahapatra. Honorable Chairman, Mr. Mahapatra, Mr. B.K. Sahu, and Mr. A.K. Chaudhary. Ladies and gentlemen, I will now take you to a different ambience with man began to identify itself from Ponjit as hominid when they picked up stones for their livelihood. So we had Stone Age, we had Bronze Age, Iron Age. Now India is on the verge of entering into marine mining age or marine minerals age. We have in Geological Survey of India, after the acquisition of research vessels in 1983, we made some, development, the finding of minerals or mapping of the marine domain. And that may not compare well with the terrestrial activities, because just think of our terrestrial area being 3.2 million square kilometer compared to what we have in the EEZ. We have an EEZ of exclusive economic zone for about 2.3 million square kilometer. 2.3 million square kilometer with just one ship. And we have got 303.2 million square kilometer of land with 3,000 vehicles. So compare this. Now, anyway, we'll come to what we have been able to discover in the marine domain during the last 40 years of his marine geological history of Geological Survey of India. This I'll skip, some statistics which says how much we have covered. This is the first ship in 1983 which has now been abandoned, decommissioned. In 2012, we acquired another state-of-the-art research vessel. This is Samudra Manthan, on which we worked. It was available for during our time. And we will go by geological mapping followed by discoveries of minerals. Now, in case of geological mapping, you take an area on the shelf. And here, I would like to tell those who are not familiar with the shelf. This is where you have, I think it is, if you can read it, the deeper part, shallower part of any continent, for in India, we have on the eastern coast about 50 to 60 kilometer wide zone of continental shelf, which is variable on the western coast. It starts from south around 50 kilometers, the width, and then goes on increasing to up to Bombay, where it becomes about 300 kilometer wide. So that is the continental shelf where we have most of the commercial activities like mineral deposits, heavy minerals, and other minerals also. Then we will come to on the shelf. This is shelf part where how the mapping is planned. We have got a grid, and these grid locations where we have to collect the samples, and then the longitudinal north-south and east-west tracks for the ship to sail, along which we collect the data, both the bathymetric data and geophysical data like seismic records. This will give us the topography of the sea. This is the later ship we have. Initially in the older ship we didn't have, but this one, why it is changing? So now from this we get the bathymetric record. This is the seismic record which gives the profile of the sea floor. Here you are finding this break in slope which indicates the end of the continental shelf. After the continental shelf edge, you get a rather increasing slope, and then it goes to the abyssal plain, which is the deeper part of the sea. We have got two kinds of sensors to pick up the picture of the seafloor. On the left, you see what you see is the seismic record, which gives the profile of the sea. On that, you can see here, what you see here, some elevations. That is repeated on the sonar image. On the right, what you see is picked up. It is almost like a photograph without the use of light, because there is no light. With the use of sound energy, these are picked up. And this is a ridge, coral ridge on the shelf edge, which is picked up on the seismic like this in the profile. And then, based on the analysis of the samples collected on all those grid points, the result gives you this map for that area. This is just to show how mapping is done on the seafloor. Now, in this, you also come across the percentage of heavy minerals in the continental shelf. The shelf, the inner part of the shelf is actually containing these heavy minerals, but not all over the shelf in India. Like in southern Odisha, we have got this heavy mineral deposits on the inner part of the shelf, which is as good as what you get on the beach. You can go up to, I mean, the concentration goes up to 20% in the sandy component. So this is only what the heavy minerals we have on the southern part of the Odisha coast. In the northern part, we don't get all these minerals. So we get some different types of minerals which are not as important as these minerals economically. Ilmenite. We have got 6 types of minerals. This is garnet, then monazite, and this one is zircon, this bottom left. In 1992 or 91, GSI discovered a huge deposit of lime mud with a very high calcium carbonate content, 71% to 95%, and magnesium is just less than 2%. But it is a huge area. It is sprawling over 3,200 square kilometer. It occupies a part of shelf and the upper slope of Gujarat. It was done in the SM Cruise 75. Similar lime mud was also discovered in the Andhra Pradesh, North Andhra Pradesh coast, where Dr. P.S.N. Murthy, Mr. Rama Murthy, and our president here, chairman here, Mr. G.P. Mahapatra, they have been part of this discovery of lime mud of North Andhra coast. This about the utility of this lime mud. There is a publication by A.C. Dinesh of Geological Survey of India. Subsequently, they also worked on this, and the importance of his observation. I'm just giving a brief. This can be used as flux material for steel, pillar and cement industries. Stone paper. Stone paper is a new thing which I have never come across, but it is there already. It has been proven. The striking difference is in the consumption of water and emission of CO2. Now, in fact, comparing this transportation of lime mud now, which is otherwise imported of this grade, limestone is imported by many industries. So the cost difference is $5 per ton if it is lime mud, $16 per ton if it is limestone import from other countries. Next is, this is a big discovery, which came much after my retirement from Geological Survey of India. Again, A.C. Dinesh was the chief scientist of the cruise, where they have discovered, again, huge area covered with the polymetallic manganese, iron manganese nodules, FEMN. This was only very recently, 2017 to 2019, and its grade is quite good. It contains a lot of rare earth elements. Coming to its chemistry, I think we have mentioned here, nickel is 1432, 1400 ppm to 7800 ppm. Cobalt is 800 to 2000 ppm. And there are a lot of REE, average with averaging 1000 ppm. This in addition to manganese and iron, which is about 22% of manganese and 26% or 28% of iron. That makes a very good discovery. This again was taken up by, I don't know what is happening. Yeah, with the help of NIOT, GSI's reference to NIOT in Chennai. They are developing a technology to extract manganese nodules from Andaman Sea. Andaman Sea, another aspect of Andaman Sea advantage is that it is at a very shallow depth, in the sense compared to what you have in Indian Ocean and Atlantic and Pacific Ocean. Those are more than 4,000 meter deeper areas. For 4,000 is the minimum. I mean, it goes up to 6,000 meter depth. Whereas in this case, it is only 600 to 1,100 meter depth where you get the nodules. And Andaman Sea itself is deeper than this. It goes up to 2,000. But here, it is on the sea mount, seawell ridge and seawell rise. So the depth is still less. And one observation by those who have worked in other manganese nodule areas, they say that formation of cobalt in the manganese nodules complex is much better when it is not at
Sir,
deeper
5
level
minutes
of
more.
manganese of oxygen minimum zone, OMZ. In OMZ, this cobalt formation does not take place. It is not congenial for the formation of cobalt precipitates. But this being a shallow area, and also it is supported by hydrothermal process, which is available here because it is a Andaman back arc spreading center, where you get, spreading center, you get hydrothermal activity. So that was about FEMN in Andaman Sea. This is the location. The map on the left is by Geological Survey of India, where they have shown this in the boxes. 2 areas have been covered. There are much more areas to be seen. Third is this geochemical scan for hydrocarbon, which we had done in collaboration with ONGC. That was on the west coast of Gujarat, where this is the map which they had actually provided us with the map of the sea floor, the structure particularly. But the structure is the useful component for this type of studies, because the oil and gas reservoir are much below, thousands of meters below this level of the sea floor. But then because of the fracture in the rocks, seepage takes place, and the seeps of hydrocarbon is absorbed in the surface sediments. And the sediments we sample, and then in ppm, we get the concentration of methane, and from that, prospective areas can be identified. This was done also by Geological Survey of India, by this ship SM Samudra Manthan. And this is the high concentration zone of methane. So the exploration could be confined to this area from out of the entire big area. Finally, gas hydrates, which have been discovered by, Geological Survey of India initially did the, locales of the possibilities of finding this gas hydrate. Gas hydrate is another form of petroleum hydrocarbon, which is in combination with water molecule. Water molecule actually holds the molecules of methane and other hydrocarbon gases. It is in a frozen condition in the shell, but it does not require, like other conventional gas and oil, you need a reservoir with a cap of impervious rock. But here it is frozen into the sediment. And that makes it rather difficult to extract. They have been able to drill core the gas hydrate. These white ones are the frozen water molecules with the methane inside it. And this picture on the left is that of Mahanadi. So Mahanadi also, they have found indications. They have not drilled in Mahanadi, but of Mahanadi Delta, there is a possibility of finding gas hydrate. But then the NGRI, like Kalachan Sai and Harsh Gupta, have published a lot of papers which says about the finding of gas hydrate in this area. Finally, the most important thing that it is in the history of mining, Indian mining history, that the government of India has issued offshore areas existence of mineral resources, and that it introduces composite license, a two-stage operating right granted for undertaking exploration. The area to be given 45 minutes by 45 minutes is the maximum area that can be given. And it can be, but there is an if, that is, if it contains radioactive minerals like monazite, then it cannot be given to private sector, but with a threshold value. If it is less than a certain value, it is open for private sector. But more than that, it will be given to PSUs. With this, I conclude my talk. Thank you.
Thank you, sir. I think recently there was an auction they have given for 13 blocks.
Yes, they will be given.
No, November they have already given. They have auctioned. They have asked for bidding for 13 blocks.
Yeah.
Not all. Only 13 blocks they have asked for.
Yes.
That is 7 is from Andaman Sea.
Yeah.
Another 6 is from Porbandar, alignment, and 3 from sand, construction sand. These are the things. Only heavy mineral they have not given. Phosphorite they have not given. Okay, sir. Thank you very much. I think we are running short of time. I think he deserves a very good clapping, sir. Yeah. Next speaker, I think Ajay Kumar Chaudhary, he has not come. So Mr. Mohanty, he is representing probably, no, sir? No, it is. Sir, please. He is Mr. Vikas Mohanty. Correct, sir? Please introduce yourself.
Good evening, everybody. I am Vikas Chandra Mohanty, currently working as Assistant General Manager Mines in the Panchpatmali Bauxite Mines of Nalco, Damanjodi. So good evening again, sir. And first of all, I would like to thank SGT team to arrange such a forum for exchange of ideas. Thank you, sir. And respected dignitaries on the dais and off the dais, fellow speakers, miners, geologists, a warm good evening to all. I'll be concluding the session of today, and it's on balancing extraction and conservation. So basically, sustainable operations at the Panchpuri bauxite mines of Nalco. Before going into it, sir, I'll take you to 1970, which made the breakthrough of aluminum to India. In 1970, the East Coast bauxite deposit were discovered. Prior to that, aluminum was never thought of a mineral which could be explored or which could be exploited economically in India. In 1970, East Coast bauxite deposit were discovered, and Panchpatmali was the richest of them. Richest in terms of the quantity in the reserves and as well as the quality. Panchpatmali, we are located in the southern part of Odisha. This is the Panchpatmali if looked from space. Panchpatmali stands for, it means Panch, 5, Pat, flat topped, and Mali, as you know, it's hills. So it's a cluster of 5 flat topped hills. These are the serene features of the mine, sir. As you can see how high we are placed as compared to Bhubaneswar per se. We are pretty cool over there. Even in the summers, it doesn't exceed 40 degrees Celsius. The rainfall, as you see, is 1600 mm is the average. Coming to the mining part, sir, we are Asia's largest bauxite mines. We are the first to mine a mine and ore from the East Coast bauxite. So we are pioneers in this industry. We are lowest cost producer of bauxite, not just in India, but in the world. It is proven in the 2018 Wood Mackenzie report. And since 2018, we are the lowest. The deposit is pretty big. It's the strike length is 21 kilometers. Reserves, as you can see, is 310 million tons. And this is how we grew, sir. In 86, we were the first to transport mineral that was 2.4 million tons. And now we are crossing 7.5 million tons. Sectionally, East Coast bauxite is much similar. And as you can see, the first meter is topsoil, followed by 2 to 3 meters of laterite. Then comes the cream, that's the bauxite, which extends up to the first part, top bauxite, 7 to 8 meters, and then bottom bauxite, 8 to 10 meters, followed by the parent rock or the mother rock, which is chondrite, but the version over here is partially laterized chondrite. Chondrite, as you see, as you know that it looks blackish in color, but PLK, partially laterized chondrite, is whitish in color, very fibrous as compared to chondrite. Coming to responsible production, sir, that is the first part. As the theme was balancing extraction. So whatever resources we have, the entire Panchpatmali bauxite mine has been modeled through SARPAC, and which ensures efficient extraction so that the losses or the resources are extracted economically. The next technological marvel we have, that is the cable belt conveyor. When India and all over the world were conveying minerals through trucks and all, we were the first one who brought in a cable belt conveyor. This is Asia's longest cable belt conveyor. It takes off in the mine and lands in the refinery, a 14.6 kilometer downhill conveyor. It just does not negotiate vertical curves. It also negotiates horizontal curves. And that's the beauty of it. Here a belt is placed over a pair of steel wire ropes, and the entire load is taken, most of the load is taken by the ropes, not by the belt, as you see in the conventional conveyors. This has been done through a very technological marvel. I will not delve into the details of it. But as you can see, sir, we are doing a great job. This is totally eliminated the use of road transport. The greenery you can see along the belt, it doesn't look like a mine. The height which we negotiate from the mine to the refinery is around 317 meters, which is roughly a few meters above the height of Eiffel Tower. In 2017, we started a semi-wall crushing plant, an in-pit crusher, which reduced the hauling of ore from the mine faces to the main crusher, which is the starting point of the cable belt conveyor which I was speaking about. It has its own conveyor. It's again a 4.3 kilometer long, but it's not a cable belt conveyor, it's a conventional conveyor. but it also negotiates both vertical and horizontal curves. It's called a semi-boil because the entire crusher unit was divided into 3 parts, which were taken on crawlers and set it up in the mine. This is in the very first stage when a truck is unloading in the crusher. We have a GPS-based fleet management system just to manage our fleet. We are India's first to think of bringing in a GPS-based fleet management system just to manage the fleet. It can manage the entire trucks. This is a graphical layout of where my equipments are running. I can see it has a vast reporter of reports. I can see from anything to everything. Anything of the operations, how my operators are doing, where my operators are working, from where I'm mining out the mineral, what is the quality of the mine, I can see it all. All these reports are also customized with SAP. Next, popularly, we break the in situ strata using blasting. That's the convention. But since long, we have been looking for alternatives. How to reduce the use of explosives? How we do it? We use high capacity shovels, which can extract the mineral on its own. We use ripper dozers just to break the in situ strata, and that also enables us in working multiple phases to avoid emission of gases. Again, a pioneer in this field, sir. We are proud to say that we use concurrent land reclamation and rehabilitation in our mines. As we mine out, we backfill the area and release it for subsequent plantation. So the mountain, as it was, it will be as it is. This is how you see, sir, the layers of mineral, first topsoil, then laterite, then bauxite. And after mining it out, we fill the laterite onto the mined out area and release it for plantation. This was the virgin area as it looked in the mine. We mined out the bauxite in 2 stages, first the top bauxite, then the bottom bauxite, and then we release it for plantation. Mining is all continuing, as well as on the backdrop you can see greenery, which we had mined out and we released for plantation. So this was what the mine was, and this is what we have done it. The jungles are literal jungles only, sir. We had a study with help of OUT, and in the core zone as well as in the buffer zone, we have species, although I'm not going into the detail of it, and we have several species which have been found out in the core zone as well as in the buffer zone. So that is why we also have a wildlife protection plan and a biodiversity protection plan in place. International Aluminium Institute way back in 2022 released an article wherein it had specifics about aluminium industry, and as per the report, per ton of bauxite extraction required 1.5 kilograms of fuel oil, means diesel. 1.5 kilograms, if translated to liters, it's 1.875. And when this report was done, just prior to that year, we had an average of 0.94 liters per metric ton, just half of it. And this is along the years, and as on this year, we stand tall to declare that at least we'll go beyond, means lower than 0.82. Towards environmental performance, we are an ISO 14001 company, and we also have Energy 50001 certificate. This photo is not downloaded by Google, sir. It has been shot from the mines. These views are just along the near to the mine area only, sir. And just on another random day of working, we had a drone, and this is how we operate, sir. One-way haul roads, empty trucks come on one road, loaded trucks go on another road. The roads are centrally mounted with risers which do the sprinkling. On the right side of the wet road, you see another road, and that's again an first timer in that area. We have a total LMV road for the movement of LMVs, jeeps and all. Because during operations, you need to involve, for supervision, you need jeeps. So if they ply on the same road, there's high chances of getting fatal accidents. So we have a dedicated road for the movement of LMVs. So for dust suppression, as I showed that we have fixed sprinklers. We also have mole sprinkler which cater to the faces. We have dry fog system at the crusher hoppers, fog cannons at the stockpiles, and the entire conveyor is covered, the entire 14.6 kilometers. So the greenery you can see is intact. We also have plantation on the peripheral barrier, the 7.5 meter barrier. We have a zero discharge system in the mine. Here, these ponds are basically the canteen wastewater which is collected over here.
Dr. Mohanty, another 5 minutes only
Yes, sir,
left.
yes.
Okay, please conclude.
This is an three-stage layering, three-stage layer process for the collecting the wastewater at the workshop. All this is filtered and the water is again reused for water sprinkling. So we do not draw any water from the parent sources. This is a 7.5 meter barrier, in situ barrier. We also have check dams to restrict the surface runoff. Canteen waste is further used for generation of biogas, and as you can see, the 15 cubic meters per day is generated through this plant, which is again used for cooking and all. Wherever we find non-mineral zones, just as clay zone, we develop them as ponds, which again is used for rainwater harvesting. We have 6 number of ponds as such. Rooftop rainwater harvesting is also done. And we are a water positive mine, sir. We consume 7 lakh cubic meters and we recharge 49 lakh cubic meters through these measures. We have our own high altitude nursery. So whatever plantation is being done is the saplings are developed in our nursery only. More than 700 hectares of the mine area has been rehabilitated. We are a mine where none of the material is called as waste. We do not throw anything. Topsoil is being used for the barriers, for the plantation, laterite, bauxite, clay, wherever which is of no use, we use it as a site for the rainwater harvesting pond. We have a butterfly garden. Every year, whoever retires, he plants a tree. So that is how we add a tree for every day. We have mango orchards, we have developed coffee, and these are the coffee beans. We have developed a Miyawaki garden, and next year we are going it large. We have eco initiatives